Hey guys, it's Mr. Wolf, and we're going to be starting our new unit on projectile motion. And it's going to be kind of like a mini unit. And so if you guys go to your packets that I handed out, it's going to be starting on. This is going to be starting on page 3, and it's going to be going to page 5. Remember, there's going to be a mini quiz at the beginning of Monday on this. As long as you watch the video, take notes, you guys should do fine at it. All right. So the targets for this unit are going to be basically the same as Unit 2. We're going to be describing motion through words, building motion diagrams, analyzing graphs. Really the only difference now is we're going to be applying these targets to projectile motion. So you guys have definitely seen examples of this before, and I'm going to put 4 here right now. How are we going to define this commonality between all these objects traveling in the air? In physics, we're going to say that projectile motion is any object that moves through the air or space and is acted on only by gravity. Air resistance could play a factor. For the purposes of this class, we're going to neglect air resistance. All right? And so it's acted on only by gravity. And so if we have an object that's traveling through the air, however it's traveling, the only force that's going to be acting on it is going to be gravity, and it's going to be going downwards. So how are we going to go about analyzing this motion? It's much more complicated than before this object, going on the floor or an object just falling down, in free fall. Now we have this object that is, going in an arc. And so how we're going to go about this is we're really going to kind of split it up into 2 main components. So even though the object may be traveling at this angle and all these different speeds at this angle, we're going to be looking at, how is this object traveling in the horizontal direction, in that x direction, and how is it going to be traveling in the y direction? Right. And so what we're going to first focus on is the horizontal direction. And so the horizontal component, the x direction of motion for a projectile is just like the horizontal motion of a ball rolling freely along a level surface without friction. And so, another example of this would be, a hockey puck, with very little friction sliding across a rink. When we were working on problems like that before, it's going to be moving in the horizontal direction for a projectile. It's going to be moving at, and I know this motion diagram doesn't show it the best, but it's going to be moving at a constant speed. And so let's kind of look back at our free body diagram of the object, and the only force acting on it is gravity. Well, this makes sense. We don't have any forces acting on the left or the right of this object. So if it's being, thrown, at this angle or whatever, it makes sense that it's not slowing down or speeding up. There's no forces acting on it. So it's going to be just moving at this constant speed in the x direction. All right. And so these check for understanding questions, what I want you guys to do is just, try them out, help you kind of prep for the quiz. We'll go over these on Monday. I'm going to skip ahead, but, make sure you do these in your packet. And so, we've looked at motion in the x direction, and when it's going horizontally, the object is traveling at a constant speed. In the y direction, we're going to treat this basically like it's in free fall. We've done this in the past unit. When an object is dropped, let's say from right here, it's going to fall to the ground, straight. It's basically going to be the same thing here. And so when our object was in free fall, it was increasing speed going down. So this was going to be a changing speed here. So when it's going in the y direction, we have a changing speed, and it's going to be increasing speed going down. And again, let's look at our free body diagram. This makes sense because the only force that's acting on it is gravity, and it's acting in that negative direction. So it's going to be increasing speed going down. All right, and again, here's the check for understanding number 2. You guys go ahead and work on this. I'm going to go ahead, and again, we'll go over this on Monday. All right, so we have 2 independent components of motion, and I'm about to bring them up right here. So imagine, a cannonball shoots a projectile, horizontally, and how is that object going to fall? Well, remember we said in that x direction, it's going to travel at that constant speed. It's not because it's in this component, this horizontal component, gravity is really not a factor. It's going to stay constant. For that y component, gravity is acting on it, and so it's going to change motion. It's going to increase its speed, going downwards. And so we've seen this from our free fall problems before. Right? So we've broken down this motion in two separate components, but we do need to combine them to show how that object is going to travel through the air once it fires out of the cannon. And so what you're going to get is you're going to get something like this. Right, the ball's going to follow an arc, and this makes sense. This is what we've seen in the past. Think of someone shooting a basketball, throwing a football, throwing any type of projectile. It's going to follow this arc. But let's go back to the components. It's going to still make sense. So let's first look at that x direction. Remember, in the x direction, our object was going to be moving at a constant velocity, right? Okay, it still is traveling at that constant velocity, even though it's going at that angle. It's still traveling in the x direction at a constant speed. Now let's look again at the y direction. Does this y component still fit? All right. As it falls, it's still falling at that same rate in the y direction. All right. It just happens to be having a horizontal component along with the vertical component as well. So the following example shows an object that is being sorry about that. An object that is being dropped, so that's the red ball, and the object that is being kind of pushed in the horizontal direction, but it's also falling to the ground. And this is really showing what the cannonball is showing, that that the two balls are falling at the same rate in the y direction. It just happens that that yellow ball is also moving in the x direction. So this was a question that always kind of puzzled me when I was in high school, working on these problems. And so from the same height and the same time, one ball is dropped and the other ball is fired. What we saw before, which one hits the ground first? When I was presented this problem in high school, the example I was given is, imagine someone is about to fire a gun, and then right next to it he's holding a bullet as well. And so at the same time he pulls the trigger, he also drops the other bullet. So the question is, which one hits the ground first? Most people think, okay, the ball dropped on the ground, just dropped, and that shot from the gun is going to fall first. What we're actually going to find is the answer is going to be that they both hit at the same time. So that's going back to that problem before, where the two balls, where one was dropped, the other one was kind of pushed in the horizontal direction. Even though one might be moving in that x direction, they're going to have that same y component as they travel towards the earth. So it's going to be at the same time. All right, and so here's another problem. Suppose a rescue airplane drops a relief package while it's moving with a constant horizontal speed and an elevated height. Assuming that air resistance is negligible, where will the relief package land relative to the plane as it continues to fly forward? So now, we have these two separate objects, the plane and the package. And so the question is when the package lands, is it behind the plane? Is it directly below the plane? Is it in front of the plane? And so how we could go about answering this is really going back to our first unit, looking at inertia, is that when the package drops out of the plane, it was going at the same speed that the plane was going before, and so it's going to want to keep on doing that. And so this is what is going to end up happening. As we'll show it, is the plane will fly. The package is going to start to fall in that y direction, but remember that x component is going to be constant. There's no force acting on it. So our answer is that when that package lands, it's actually going to still be directly below the plane. All right, and so basically this concludes it for the video. Just a couple things for the quiz. If you guys focus on this problem right here, check for understanding number 4. If you look at this problem right here, focus on check for understanding 3, and make sure that you guys understand what's going on right here. You guys will be plenty fine for the quiz coming up on Monday, and I will see you guys then. Bye.